Hello, folks. Today I'm alone. I gave my son the rest of the day off. He's got some other stuff to do, and anyways, I wanted to tie a couple loose ends from yesterday, and so I told him that he could take the rest of the day off. He's the boss, so when you tell the boss to take the rest of the day off, he does. Doesn't usually work in the opposite direction, but yeah, it does in that. Anyways, yesterday we left off with a question or a situation. I said, that you more or less need to understand what happened to past extinctions, to how they occurred, and we've had several big mass extinctions in the history of life on Earth. There were probably many, but there were what are known as the Big Five. And I think we need to understand what happened in those extinctions before we can talk about the extinction of man. We have to have an idea of, how extinctions might have happened. And the question that was left at the end of yesterday was that, at least the way I look at it, all extinctions, all mass extinctions happen in the same way. And you say, well, that's, my son asked, especially that question, he said, well, that's a big assumption there, it's quite a leap of faith. And I'm saying it's not. I want to justify that they must happen all in the same way. Partly because, just intuitively, Mother Nature is not so sophisticated. She doesn't use one mechanism per species or per habitat. She does it all in the same way. In fact, if all these mass extinctions involve, as I'm going to show in a minute, involve the food chain, it's very unlikely that she would use different mechanisms, different agents for different species, different habitats, different temperatures, whatever other variable you can think of. She does it always the same way. That's my gut feeling. But I'd like to do more than just give you my gut feeling. And I've got some gut, a beer gut. I want to give you a little more than that. I want to justify that to some degree. And yes, I will be using evidence. But the evidence is not to convince you, to persuade you. The evidence that I'm going to bring into play here is to justify different steps in the thinking process, in how I reason this thing out. And again, this is for your benefit. I mean, you're paying all those mighty bucks to get an education here, right? So this is a good time to get that education, at least to see a different view of the world that you won't see out there. So, you won't read it out there. You'll see it here. Okay, so let me get going here. What is a mass extinction? Well, mass extinction is when a whole bunch of animals die. That's in general terms. More specifically, it's the end of a food chain. One food chain disappears, the entire food chain disappears, and a parallel one that was not part of that food chain continues. Okay, that's a mass extinction. There has never been a mass extinction where all species and animals die and all plants die. That's never happened. And that's what you would expect from asteroid hits and all this other stuff. In fact, I showed a picture yesterday of the entire Earth burning. Nothing could have been left alive on such an Earth. And here we are, the mammals, we're kings of the planet. And so, no, that never happened. But that's what the asteroid theory or hypothesis insinuates, that if the entire Earth was burning, all life came to an end. And that's not the case. It's never been the case. And so that's one of the reasons I also object against the asteroid proposal. But, there's been apparently 5 big mass extinctions. And they get this because they do an analysis. Here I'm going to show this. This is a graph that was published some time ago, and it's very popular for any person doing extinction or researching extinction. It gives you an idea of how many species disappeared in each of the major events. Okay, and again, there's big 5. There's a 6th one happened around Kungurian in the about 270 million years ago in the middle of the Permian. That's also being thrown in there now, and ours would be the 6th or the 7th if we consider that Kungurian mass extinction, then ours would be the 7th. But again, I'm saying now we've had a lot more mass extinctions than that. We had extinctions all the way to Cambrian. But we're just going to look at these big 5, okay? And here they are. You can see them here. They you've got the OS, which is the Ordovician Silurian. You've got the late Devonian. You've got the Capitanian. That's the again the one that they say occurred about 270 million years ago, right before the Permian extinction. And then you have the Triassic to when it switched over to Jurassic, and the last big one, which was the Cretaceous, Tertiary, KT, or in this case, Cretaceous Paleogene extinction. And ours is that little H at the last, near the end there, and that H is the Holocene extinction. That's apparently the one that we are experiencing these days. In other words, there is an ongoing mass extinction, according to many observers, many theorists. They say there is an extinction going on. We're losing in a very short geological period of time. We're losing lots of species and also individual animals. So this is one of the theories out there that we are undergoing a 6th mass extinction if we overlook the Capitanian there 270 million years ago in the middle of the Permian. What causes do the experts, the paleontologists, the anthropologists, the geologists, and others that look a little bit at the past extinction, what causes they offer? And here's a summary of them. This is out of the Wikipedia. You see that you had flood basalts, the sea level fall, the decline in sea levels, impact events, comets, asteroids, that sort of thing, meteors, global cooling, global warming specifically because it's a hot topic today in the world among politicians and among conservationists, and that's right up there among the most popular ones. Then you have one I mentioned yesterday, this clathrate gun hypothesis, got to do with the release of methane. You've got anoxic events, that's that the oceans are starved of oxygen. You have the hydrogen sulfide. Again, emissions from the seas, the oceanic overturn, a nearby nova or supernova or gamma ray burst probably from a supernova. That's one that's at least proposed for the Ordovician. It was sponsored by NASA, so it's got official backing. You have the geomagnetic reversal. The Earth turns either I've heard it in 2 different ways. One is that the magnetic field of the Earth switches from north to south, and the other one that the Earth itself turns around. And when that happens, I think it's every 26 million years, well, then you have some kind of event, or that affects somehow the animals on the surface of the Earth. And you have also the final one, plate tectonics, a couple other hypotheses involving, disease and competition, that, a new species outcompetes the old one. And then you have, other comments there about the future biosphere and so on. And I guess that's got to do more with us. So these are in general what people are proposing. What are these causes? Do any of them in any way resemble what I'm proposing? Well, for sure not. This is essentially what I discussed yesterday. These are the causes that are offered by people such as Guy McPherson. He's the guy who chooses among these because they're all environmentalists, and these are all environmental type events or mechanisms. Let's go with the first one very quickly. Let's see if we can run through them. This is the flood basalts event. It could have produced dust and particulate aerosols, which inhibited photosynthesis and thus caused food chains to collapse both on land and at sea. Okay, so that's the mechanism that's being offered. The other one is that these basalts emitted sulfur oxides, which were precipitated as acid rain and poisoned many organisms, in contributing further to the collapse of food chains. And I want you to notice that in both that first one and this one, they talk about food chains. They mention the food chains, but it's something that killed the food chains, and it's something which is environmental. And so the other issue I've got with this, especially the second one, says, acid rain and poisoned many organisms. The question is, why didn't it poison all mechanisms? You would think that acid rain, if it fell to the degree that it killed a species, why didn't it just continue killing all or several species? Because we're talking about a mass extinction here. Why didn't it kill all species? Why would any species survive? And this is one of the issues that they always fail to address. And the main issue here, the underlying issue, is selectivity. They have no way of explaining selectivity, and they have never explained selectivity. The way they get around it is by applying a different mechanism per species and a different one per habitat. So, the fish weren't killed by the same mechanism that the birds were killed or the animals on land. No, the fish have to die because the waters became too acid for them. And that's fine, but then why didn't all the fish die? Why did some fish survive or some marine animals survive and others did not? And the same on land, the issue is selectivity. And if you're going to use one mechanism per species or per habitat, well, then you're eluding the issue that you must address, which is selectivity. And selectivity points to a single mechanism, and then the question comes, why do we have to have a single mechanism? Why can't we have one per species? And that's when it gets quite complicated, and I think you have to introduce a little bit of William Occam in there. You got to go with Occam's rule and go with the simplest. And that's another underlying thing you should keep in mind. Anyways, the last one is emitted carbon dioxide, and thus possibly causing sustained global warming. Again, this global warming is because of what's going on today, and people are very hot on this topic. You have the Kyoto in Japan, the environmental gathering, and they always deal with global warming and stuff like that. And so this is a hot topic, and that's why it's always mentioned among the causes. But the question is whether global warming has any relevance whatsoever to extinction. And again, it's because once the dust and the particular aerosols dissipated, you still have global warming. Okay, so that's the flood basalts. And again, flood basalt is volcanic eruption. And what you have is lava with rocks and whatever, heated rocks, igneous rocks, and that allegedly, just created such a monster in the atmosphere that just killed the animals, either through the blocking of the sun, or precipitation as acid rain, or emission of carbon dioxide or other gases. So that's the first one. Then we go with the sea level. And, sea level falls, so what does that have to do with extinction? Well, it could cause a marine mass extinction and could disrupt weather patterns enough to cause extinctions on land. What it does is reduce the continental shelf area where most of the animals are born in the ocean. Impact, those are very famous. We can't forget those at all, because impact does explain suddenness, spontaneity, and that's what they like about impacts. And again, we're talking about large asteroid, comet, maybe a meteorite or whatever, something from the sky, came out of the sky. Cretaceous used to sing, and that's essentially what this is. And so you have to kill animals on both land and sea, and the way you do it by producing dust and particulate aerosols inhibiting photosynthesis. That's one mechanism. The other one is impacts on sulfur-rich rocks. One of the theories, especially for the dino extinction, is that the the asteroid fell on sulfur-rich rocks. Just, the dinos were really out of luck, specifically the mosasaurs, the sea reptiles. They were in deep trouble because the impact, the asteroid hit sulfur-rich rocks. The sulfur went up into the air, and now it fell down as acid rain, which killed all the mosasaurs. Otherwise, they had no other mechanism to kill them. So again, we're having all these coincidences that are just so convenient to explain why some sea creatures died. But then again, you can't explain the selectivity, why some and not others. And again, you see it mentions the collapse of food chains. You'll see quite a bit of that. In fact, all of them essentially mention food chain either directly or indirectly. And, again, the impact also could cause tsunamis and forest fires. So that's, they have to destroy the environment somehow to show that why the animals died, but then again, they can't explain the selectivity of it. Here is the global cooling, and we also have the global warming. And we're all more familiar, especially with global warming. In case of global cooling, we have sustained and significant global cooling could kill many polar and temperate species and force others to migrate towards the equator, reduce the area available for tropical species, often make the Earth's climate more arid on average, mainly by locking up more of the planet's water in ice and snow. And the global warming, well, yeah, we would have the opposite effects: expand the area available for tropical species, kill temperate species, or force them to migrate towards the poles, possibly cause severe extinction of polar species, often make the Earth's climate wetter on average, and mainly by melting ice and snow, and thus increasing the volume of the water cycle. It might also cause anoxic events in the oceans. And there's a little bit of a contradiction there, because the first, you heard earlier, one of the proposals is that the sea levels dropped. And here they're saying the volume of water increased because there's global warming. And so, either the seas dropped or they rose. They can't be both ways. And if, as they say, that in all 5 mass extinctions, the big ones, right, the sea levels have been measured to have fallen, then global warming should be removed from the list of at least the 5 big mass extinctions. But they throw them in there anyways, even though the evidence that they collect, debunks it. So either the sea levels rise or they fall. And all 5 big mass extinctions, they say the sea levels dropped. They went down. So it's a question that's got to do with the new species that are being born near the shores in shallow waters, right? And here they're saying, global warming would, melt the ice caps, and suddenly you have instead, a rise of the ocean levels. And so, again, they have all these contradictions, and it's like they don't pay attention to their own evidence. Okay. Another famous one, the one I discussed yesterday, methane clathrates, in which water molecules are the cage, form on continental shelves. These clathrates are likely to break up rapidly and release the methane if the temperature rises quickly or the pressure on them drops quickly. For example, in response to sudden global warming or a sudden drop in sea level or even earthquakes. Methane is a much more powerful greenhouse gas than carbon dioxide. So a methane eruption, clathrate gun, could cause rapid global warming, again, or make it much more severe if the eruption was itself caused by global warming. And again, they use this term global warming, which is so popular today among politicians and conservationists, because it's a buzz term. But it turns out that, the 5 big mass extinctions have been measured to have lower sea levels. And I'm sure they're going to change that if they need to accommodate global warming in some way. And another one is the anoxic events. That means the oceans are starved of oxygen. Are a situation in which the middle and even the upper layers of the ocean become deficient or totally lacking in oxygen. Their causes are complex and controversial, but all known instances are associated with severe and sustained global warming, mostly caused by a sustained massive volcanism. So we have asteroids, volcanism, global warming. Those are the frontline theories. And every now and then they mention in passing, that the food chain collapsed. So keep that in mind. Another popular one, I discussed that a little bit yesterday, and that's that 3 authors there have proposed that during the Permian-Triassic extinction event, the warming also upset the oceanic balance between photosynthesizing plankton and deep water sulfate reducing bacteria, causing massive emissions of what? Of hydrogen sulfide, which poisoned life on both land and sea and severely weakened the ozone layer, exposing much of the life that still remained to fatal levels of UV radiation. And the question again, if this is what happened, why didn't it kill all of life? Why did all the plants survive? Any plants survive? Why didn't they all die? Why didn't all animals and plants die if this is this gargantuan catastrophe, accident of nature? Act of God? If this happened, why didn't all animals die? Why didn't all plants die? And again, none of these mechanisms address selectivity. They've forgotten completely about this word called selectivity, about this issue. Next one. Oceanic overturn is a disruption of thermohaline circulation, which lets surface water, which is more saline than deep water because of evaporation, sink straight down, bringing anoxic deep water to the surface. And again, it's a question of how much air is available at the surface of the waters, and therefore killing most of the oxygen-breathing organisms which inhabit the surface and middle depths. One problem here is, a lot of fish and so on, water animals, they deposit their eggs, in shallow waters. And the question is, if this happened, again, all these animals should have died. And I'm not sure that's the case. I'm not sure there's, they can produce any evidence of that. It may occur either at the beginning or the end of a glaciation, although an overturn at the start of a glaciation is more dangerous because the preceding warm period will have created a larger volume of anoxic water. Again, anoxic water, why didn't every animal die if they were starved of air? Nearby, I love these two. Nearby gamma ray burst, I love that one. It's got to be less than 6,000 light years away for it to be powerful enough to destroy the Earth's ozone layer. So we destroyed the ozone layer. Now the sun's rays can penetrate and kill what? Every animal and every plant on Earth, right? No, they never addressed that issue. Leaving organisms vulnerable to ultraviolet radiation from the sun. Gamma ray bursts are fairly rare, occurring only a few times in a given galaxy per million years. Okay, so that's how they kind of justified. The main one that is being proposed for gamma ray burst is the Ordovician extinction. They say that's what they think happened. Again, it was sponsored by NASA. Why? Because NASA is concerned about people paying attention to what happens in outer space. And here they had an opportunity to do a little PR, you know, and they say, hey, you know, if we stimulate these guys who are doing research on extinction, and we relate that to to space, to whatever happens out there outside of the Earth, a lot of people will probably pay more attention to our own programs. So I think this is just propaganda. That's all it is, because it has no merit whatsoever. Especially when you look at the mechanism. The mechanism is that the gamma ray simply blew off the Earth's atmosphere, and then somehow we recovered it. I don't know how far back after that, you know, maybe a few years, a few decades. But the issue is that they're saying that it blew the entire what is it, the smoke or the covering that the Earth has of atmosphere. It just blew it out of the Earth, and that to me is sounds more like a cartoon. I can't even take it seriously. Periods of increased geomagnetic reversals will weaken Earth's magnetic field long enough to expose the atmosphere to the solar winds, causing oxygen ions to escape the atmosphere in a rate increased by 3 to 4 orders, resulting in a disastrous decrease in oxygen. Okay, so you can see what all the papers that are being written on extinction are all about. Plate tectonics, movement of the continents into some configurations, can cause or contribute to extinctions in several ways: by initiating or ending ice ages, by changing ocean and wind currents, and thus altering the climate, by opening seaways or land bridges which expose previously isolated species to competition for which they are poorly adapted. In other words, the introduction of new species into a different environment simply because of plate tectonics. The Earth moved, and now animals can cross, you know, without a visa. That's essentially what these people are saying. And then the final ones, here you have others, and one is disease, or the other one is a simple, one species outcompetes the other. Because they have a successful biological innovation, but all have been rejected. All of these other hypotheses have been rejected, usually for one of the following reasons: they require events or processes for which there is no evidence. They assume mechanisms which are contrary to the available evidence. They are based on other theories which have been rejected or superseded. And so they reject the establishment rejects disease and competition, and so that's about it. That's in a nutshell how paleontologists, geologists, and all these people who are interested in extinctions, that's how they view how extinctions happened in the past. Okay. And that's it. You can see that they're all chemically leaning in a chemical direction. They say that there's been some lack of oxygen. There's been too much methane in the air. That affects the climate. There's been too much hydrogen sulfide released. It's all like, we're going to kill you through heat, through burning, through some gargantuan catastrophe that killed many species. And since it's not selective, the first question is, why didn't it kill all species? Why did any species survive? Not only of animals, but also of plants. And that's the first problem we have with this. The other issue is that it doesn't make room, and this goes to the question that, with which I started, and that's the one asked by my son Adrian yesterday at the end of the lecture. And that's, I'm making an assumption, a big leap of faith, that all these extinctions, the mass extinctions, happen in the same way, and that I only need one mechanism. I don't need one per species. And those are like leaps of faith, right? But I'm saying there's something we can guarantee. Listen to this. Saying something we can guarantee. What is that? And that is that if we are standing at the Cambrian line, 542 million years ago or so, if we were standing there, we could predict that some plants are going to disappear periodically. And I'm not talking about just one species or even many species. I'm talking of whole orders, entire families of species that disappear. Why? Well, they have to disappear because first they intermarry. They inbreed for millions of years. Now, you know what happens with inbreeding. Probably heard of the Amish. They've been inbreeding for the last 500 years. And now they're starting to have, kids with 6 fingers. And they're having genetic problems. Why? Because it is, and you've probably heard also the main son of, the only son of the Romanovs. He was born with hemophilia. His blood did not clot. And that's because, if you look at all the all his cousins, they all look the same. If you look at William of Germany, who was a cousin to Nicholas Romanov, they were all grandsons of Victoria, Queen Victoria. And, there was quite a bit of intermarriage, and I think we're all aware that inbreeding causes problems in the long run. And that's what happened to the plants. The plants have been inbreeding for a long time. You say 1,000 years, that's nothing. But when you're talking about millions and millions of years, 100 million years, now you got a problem, because now, these guys are throwing pollen and just breeding and having more of the same, year after year, million of year after million of years. And after a while, they wash out their genes. There is a genetic evolution, and that evolution is always bad. And when those plants die, the animals that forged a relationship with those plants, that were born with those plants and died with those plants, all these families of species from day one all the way to the end, to the last, they have millions of years of adaptation to those plants. They cannot change at the last moment because they've got it in their blood. They've been born with that food, and now this food is disappearing because it's suffering its own cycle. And so what I'm saying here is that if you stand at the beginning of the Cambrian, 540 million years ago, you can predict that periodically entire families of plants are eventually going to die, and they're going to be replaced by new plants. And here's the graph. Here's the synthesis of that. I made this graph a while back, and I still stand by it, and I think it summarizes what I'm saying quite well. And here we're looking at the big picture. Very, very, very big picture. We're talking about millions of years here. In the first one, we have from 415 to 300 million years ago. That's 115 million years. Second group is 300 to 200 million years ago. That's 100 million years. And again, these are not scaled property. That's not the point. The point is that, every 100 million years or so, we have new types of plants dominate the planet. They kick out the old regime, and they install themselves. They spread. They cover the planet, and the old plants, kind of recede, and they have fewer varieties, fewer quantities. Okay, and the new plant takes over. And then that one is also superseded by another one that comes around, that is born, which is more efficient perhaps, more dynamic, more modern, and kicks that other one also out of the pedestal, no longer king. And now we have a new king, and then that one also gets kicked out by a new one. And what do we have here? Well, we have in the Devonian Carboniferous in general terms, right? Here we're talking about very, very general terms. We're saying we had the non-vasculars and the early vasculars. And vascular means that it can conduce water and nutrients within the plant. And the first plants had no ability to do that. They were very, very primitive plants, and they just came out of the water. They got onto land in the Devonian and even before that in the Silurian already. The Cooksonia came out, and that, we're talking about here 400 and plus million years ago. And these plants came out. They were very primitive. The original plants had no vascular tissue, and they were replaced by vascular plants, which were more efficient. And among those are all the others that came after that. The ferns, which you'll see primarily in the Permian Triassic. Towards the end of the Carboniferous, they were already becoming dominant. Then those are replaced by the gymnosperms in the Jurassic and Cretaceous. And these are the conifers. And those are replaced. And remember, we're talking about these plants were kings. They covered the entire planet. And now these plants are being replaced today. They've been replaced for the last 65 million years at least by the angiosperms. And those are the flowering plants that we have today. And they include all kinds of, stuff that we eat, including weeds that we don't eat, by the way. Okay, that's important too. And here I have it in a different way. Let's see if I can show this. Where is it? Here it is. Okay, these are typical plants that just visually, so that you can see what has happened throughout time. You have Cooksonia that appeared more than 400 million years ago. It was a first vascular plant. It came out in the Silurian. And the Cooksonia type plant, it's a type of plant, by the way, it just covered the land. Okay, it just covered the land. That was almost the only plant or the only type of plant that existed, and it was kicking out the non-vasculars. And what came next were horsetails and club mosses in general terms. They were superseded eventually by the ferns, especially the seed ferns that took over in the Permian and the Triassic. One of the most popular plants in the Permian was Glossopteris, the Glossopteridae, and they went extinct 252 million years ago, approximately. They were replaced by another seed fern called Dicroidium, and those lasted until the end of the Triassic. And again, these were families of plants, and this is what the animals ate because there was nothing else to eat. This was their corn, this was their wheat, this was their grapes and potatoes. This is what they ate every day for millions of years. And what happened? The dicroidiums disappeared 200 million years ago, coincidentally with, all the archosaurs. What came next? Well, these plants existed before they came into, to be big plants. They already were developing along, 50 million or so years earlier or more. But the issue is now they become the dominant plants. What plants become dominant in the Jurassic? The Williamsonias, the cycads and cycad-like type of plants. And that's what they look like there. You see it there. And they lasted till about 70 million years ago, as far as I know. The cycad-likes, the Benedictales, as they're known, these plants died off maybe 5 million years before the Cretaceous. And so a lot of animals that depended on them started going extinct. And there were still cycads there. And when those disappeared, pretty much, or their forests depleted to critical levels, that's when the dinosaurs disappeared. Why? Because the herbivores had nothing to eat. That's what they ate. and the plants were gone, and now they had nothing to eat. It's just that simple. And you also had conifers, tall ones like Araucaria, and pine trees of different kinds. And these were the plants that dominated the landscape. What took over? Well, the last group there, the angiosperms, and they're the magnolias, the grasses, especially corn, wheat, roses, flowering plants, fruit-giving plants. And this was poison to the dinosaurs. I'm sure that when they saw grasses covering the land, they didn't know what to do. They just stepped on it because they had no use for grasses. In fact, we have no use for normal grass. We have use for other grasses because wheat and corn are grasses. But we don't eat the typical grass of what we call grass. The lawn, what we mow with a lawnmower, we don't eat that grass. And so we don't eat all grasses. And for sure, the dinosaurs had no use for any of these plants. When these plants dominated the landscape, the dinosaurs were gone. And here's more evidence. And again, the point is not evidence, but to show you that the theory is consistent with what we see here. This is known as the Cretaceous Terrestrial Revolution. It was a 4-year study, and what they did was look at what happened throughout the Cretaceous. And they say what took over, no doubt about it, were the angiosperms. These are the number of species, and you can also multiply that times quantity. There were more quantities of these plants, and they cornered all the other plants, especially what the dinosaurs ate: cycads, conifers, and other gymnosperms, and ginkgos. All those. The only ones that they probably did not eat were ferns. I suspect that ferns were poisonous, like they are to us. They were probably poisonous, or at least they were weeds as far as the dinosaurs were concerned. And the ferns were really of the era, what is known as the mammal-like reptiles, or they're known as synapsids, or they're known also as therapsids. You've got a whole bunch of types of animals that were dominant throughout the Permian. The most famous is Dimetrodon, and he's got this big sailback. Okay, so if you've seen this lizard with a sailback, that's him. And he lived in the 300 million years ago to 250 million years. Really, he disappeared like 270 million years ago. He lived like 20, 30 million years. And throughout this time, what did they eat? Well, they ate ferns, specifically seed ferns. And those were replaced by these cycads, conifers, ginkgos, and other gymnosperms. And those were replaced by the angiosperms at the end of the Cretaceous. And that does give you an idea of why the theory is consistent, the theory that I'm proposing, that it's a food-related extinction, mass extinction, right? It's a food-related one. It takes out a food chain. Why? Because the primary production disappears. The animals that were used to the conifers, ginkgos, and other gymnosperms, etc., cycads, could no longer find the big forest, the jungles and forests of the types of plants they depended on. And when the herbivores died, so did the carnivores. And again, the issue here is that let me put myself back here. Where am I? Here I am. So the issue here is that if we're standing at the starting line of the Cambrian, 540 plus million years ago, we should be able to predict that periodically there's going to be some plants that disappear, some families of orders. I'm talking about, countless species here. They're going to disappear. That whole order is going to disappear. For example, all the seed ferns. They're going to disappear, and they're going to be replaced by what? Well, they're going to be replaced by conifers. And then you have the era of conifers and all the animals who establish a relationship with conifers, because that's 90% of what's out there. And so all these animals carve niches inside those plants. And now comes the, the angiosperms, the flowering plants. They displace the conifers, not to mention the ferns, that they also get kind of cornered out. Fewer species of these, lots of species of angiosperms, flowering plants. But these are plants that are weeds or poisonous to the dinosaurs. They don't eat that stuff. Who eats that stuff? Well, the animals who grew with it. When the grasses were growing, the little animals, us, little rats and so on, Purgatorius and so on, little animals from the from the ancient times, they expanded with the grasses, with all kinds of angiosperms that were just developing. They were small plants yet. They who knows how small they were, but all these little animals, that's what they developed with. They carved niches in the different angiosperms that were developing. And when these angiosperms started cornering, the market, when they started pushing out all the conifers, all the, especially the cycads and bennettitails, the cycad-likes, the Williamsonias and so on, they started pushing these plants out. And that's what the dinosaurs ate. And so you can see that it is a food-related extinction. A mass extinction is a food-related extinction. And why is that important? Well, it's important for human extinction. Because I'm saying that that's what's going to happen to us. What's going to disappear is food. So keep an eye on food, because that's what causes a mass extinction. And of course, the Disneyland economists, as I call them, some of you who are watching right now, in fact, they say, well, Bill, we produce, as much food as we want. Food's not an issue. It's not an issue, and again, as long as there is money. But once money disappears, I think we all can agree, not that you agree with my theory, but I think you'll agree that if money disappears, if God were to come with his magic wand and make us all stop believing in money for whatever cause, he just waves his magic wand, and instead of making it rain for 40 days and 40 nights, this time he comes with a different solution. He says, I'm going to make everybody become an atheist in money. Nobody believes in money anymore. Okay? Now, I think you're going to agree with me that if that were the case, if money disappears, there's no incentive to produce or distribute food. And again, we come back to food. Without food, for sure, we die. That's guaranteed. What you are not in agreement with me probably with is that, that money's going to disappear. But if we concede that money disappears, I think you're going to agree with me, at least on this point, that if money disappears, there's no incentive to produce or distribute food, and we all die. 8 billion of us in a matter of weeks, or whatever amount of time the food we have stored out there lasts. Which means that, it doesn't take too much long after that for all of humanity to go away. And all of this happens in a geologically swift period of time. That's my theory. You don't have to agree with it. I just want you to understand what I'm saying. I'm saying that if money disappears, and that's a big fight that we're going to have in Buenos Aires at the conference for sure. But if money were to disappear, okay? If we stop believing in money, we become atheists in money. In God we don't trust anymore, right? The dollar bill. Then there's no incentive to produce and distribute food. And if we do that, for sure, all of humanity dies. 8 billion of us. We don't need any chemical reactions of methane. We don't need any chemical, anoxia or any burst of gamma rays from a supernova. We don't need any of those gargantuan Hollywood flashy effects to kill humans. They're very interesting. If you want to go watch a movie and say, oh, look, I saw a movie where, the supernova, killed half of mankind. Yeah, that's great. Love it. But we're talking about real things. We're talking about putting our feet on the ground. And as you can see, none of the proposals that these people have for causes, for mechanisms, have anything to do with genetics, okay, of either plants or animals for that matter, And none of them have anything to do with the overturning of the population pyramid, of a species getting older. They don't believe that a species can grow old. And we're an old species. Humans are an old species because, we've, since 1963, our population pyramid has begun to overturn. We're producing fewer children. That means we have fewer and fewer young people and more older people as time goes by. So our population pyramid has already overturned. And that's 50 years of it already. 55 to be more accurate. And that's irreversible. Once the population pyramid overturns, you never overturn it again. There's no way women in the cities are going to have 10 children again. In fact, more than likely, they're not going to have any. So believe me, the population pyramid has overturned already. It's going to continue declining the population. In other words, the birth rate is going to decrease ever more and more as time goes by until we reach zero population growth at some point, and it's just going to decline. More people are going to die than are going to be born, and so that causes the extinction of man in a different way through a population pyramid inversion. And I'm saying the mass extinction is going to occur before that. Why? Because when population drops, you won't have as much demand. That's going to cause also a problem on our economics. What is the supply and demand curves? What's the demand side? It's population, essentially. It's population. You can't have more and more demand with fewer and fewer people. You can't have, a company cannot expect to sell more and more cars if there are fewer and fewer people. You cannot sell more and more houses if there are fewer and fewer people. So those markets will collapse. They will crash at some point when population is saturated with whatever they need, cars, houses, whatever, and that's when you start running into trouble. And that's another aspect of it. But again, that's a long story to discuss in Buenos Aires for sure, over a couple beers. But the important thing that I'm saying is that an economic collapse, if we make money disappear, for whatever reason, magic wand if you want, for sure we all die because no one's going to produce or distribute food. And none of these causes that I just read here a minute ago address that. The other thing none of them address is what I said at the beginning, and that's that you should be able to predict that plants are going to disappear periodically. And that's before man, before we came aboard. We're talking about just nature here. The plants are going to suffer their cycles, and they're going to die. And a new plant comes up and replaces it, and another family of plants or order of plants comes later. And what happens to the animals that develop a relationship with those plants? They've got to go. So where do we find anywhere on the internet? I challenge you, Wikipedia or anywhere you want on the internet. Find me where there is a theory that says that plants will periodically disappear and the animals that force a relationship with them disappear with them. And that's a predictable thing. It should happen. I mean, in retrospect, we went back to the Cambrian, we should expect that to happen. And there should be at least one theory that mentions that and says, look, the ones in the Carboniferous died because, the plants died because it was predictable that they would die, and all the animals that forged their relationship with them died with them. There's no such theory out on the internet when I'm telling you it's already predictable. And if not, you have to challenge me on that one. Okay, we'll see you tomorrow. Hopefully with my son, I'll bring him back tomorrow. Okay? And we'll see you then. Bye-bye.